Hello, everybody. Thank you for coming. Node.js streams under the hood, across the web, and into the future. I'm Carlos Espa. I'm a staff engineer at Nearform. You have the remark QR, so you can hit me on LinkedIn if you have any reach outs. I work for Nearform in case any here doesn't know Nearform, which I think it's not very probable if you attended the introduction. But what you might not know is that we have open source deep in our core. And one thing that I think is particularly interesting is that we are the 7th most active Node.js contributor, which I think is pretty impressive because if you see other companies that high up in the ranking, they are like n times bigger than we are. So I think that says something very positive about us. So if you are looking for new opportunities for a new role or for a new partner for your company, you can hit me on LinkedIn and we can talk through it. So, Node.js streams. You probably heard a lot about them. They are a great way to handle large sets of data, especially if you can fit them in memory or if they are only available over time. Usually, when you work with streams, you have some input, which would be a writable stream. Then you want to make some transformations to it. And at the end, you have to output it somewhere, which would be the writable stream. This is the example that I'm going to be using throughout most of the presentation. It's pretty basic, but we read from the file we are executing, we transform it into uppercase, and then we output it into the terminal. Nothing fancy here, just to showcase a bunch of behaviors. Cool. Pipe was in Node since the beginning. At the beginning, stream classes didn't even exist, but since version 0.4, which is quite early, we got stream classes and we got the pipe method. And afterwards, in version 10, which was released in 2018, we got this pipeline method, which basically does the same, but we can pass all the streams there, and we get the pipeline. So, well, to start with, this version, which is the async version of the pipeline, was released in version 15, so 2020. You need to have that if you want to use this version, but probably most people here should be using later versions. So why was pipeline created? We already had pipe, so why do we do this? And to understand this, we have to get into the internals of Node.js. I had a little metaphorical chat with Node.js, and I was like, OK, can I use pipe? And you shouldn't really unless you really know what you're doing. But why? Error handling is complex. How complex? Well, this is the implementation of the pipeline function, which is the things that pipeline does that the pipe method doesn't. Also, I'm actually not being fair here, because this is only the first level function, which is calling other functions which have similar lengths. So you can imagine how much code you need to actually do this right. OK, but even one of those functions is end of stream, which used to be a whole different NPM package. And it got discontinued 5 years ago because it was merged into Node Core. And what is this doing? Well, if we are simplifying a lot, and really I mean a lot, you've seen the other parts, we are adding a bunch of listeners to the streams. It depends. We don't always add all of these because it depends on whether it's a writable stream, a readable stream, or if it's a duplex transform stream, we need to add both of them to each of them to its ends. And then it's taking care of tracking all the resources on the pipeline. So when the pipeline ends or when we have any error, we can clean up all the resources. OK, and then we have some sorts of different things that handle like weird cases, like what happens if one of the streams is already closed when I use the pipeline, or what happens if I want to have an abort controller and send a signal if I want to stop the stream for some reasons, and many other stuff. So we can think what would happen if I don't use pipeline and I stick with pipe. And one way of thinking of this is, OK, let's try. If we have an error, what would happen? I'm running this over a loop so we can have enough mass to see the effects. But basically, you can think of this as if I had a server open and I was receiving requests. I don't expect my server to fail on all the requests. But if it fails sometimes, it can be due to a variety of reasons. Maybe the resource is not available. Maybe I have a complex transformation that fails under certain conditions and stuff like that. This can build over time. So to simulate this, we are just returning an error in the callback. Then we have to add an error handler just to avoid having unhandled exceptions being thrown. Please don't do this. Don't have like empty error handlers. I think it's pretty obvious, but just in case. And then basically I try to listen to the close event on the readable stream, which is what should be fired before all the resources are released. And if we run this script, we will get no output from the error events. And why is that? Because we are using pipe. And pipe is not aware of the whole pipeline. So if I have an error on the transformation, I have no way to tell the readable stream, OK, we had an error. You need to close. So I won't get this. If we run this script with the trace.gc flag, which basically logs all the events for garbage collection, we should get something like this. Of course, it depends on what's your machine. But if we clean up a bit this mess and leave only like the important data, here we have different steps of the garbage collection, and on the left side we have the amount of megabytes that were allocated in memory, in the heap memory, before the garbage collection, and then how many of them remained afterwards. So what we can see is that they are steadily increasing, and also we can see something interesting, that is in the mark compact phase, which is the major phase of garbage collection, we have almost no release of resources, which is pretty significant. There's a guide in the Node.js website, which is about tracing garbage collection. And one of the things they say is that you can try to run this with limited heap space. And if you keep seeing that you increase the size of the heap and you still get an out-of-memory error at some points, there you have a memory leak, which would happen if we did that here. So if instead we go with the pipeline version, we just have to put the close event on the readable and use the pipeline. If we run this, we will get the close event because pipeline is handling that for us. So if we do again with the garbage collection, I already cleaned it up because you already know how this looks. We can see something very different. Like the heap memory, it's increasing because the program is still running, but it's increasing very slowly, and we can see that on the mark compact phases, we have significant releases, more than half of it. So here we don't have that memory leak. As I said before, you are not expecting to have all the resources failing all the time, but if you have a server, this really can build over time, and you can have like service degradation. Cool. So we all know that we need to use pipeline, and we know how to handle our Node.js streams. But I heard there's something else than Node streams. There is like something called web streams, which are part of the web standards and were added to Node. How does that play with all this? And if you are using pipeline instead of pipe, which you should, probably, then I have good news for you. Because pipeline just handles it perfectly well. Like it handles node streams, it handles web streams, and it handles also iterators. So you get these benefits for free apart from good error handling in your node streams. And how does it do that? Well, in this table, we can see if you go into the internals of the pipeline implementation, we can see that you have to handle all the cases. There is a big if-else chunk there that has different behaviors depending on what the input and the output functions are. If you have a node stream input and node stream output, you just go with pipe with all the error handling that needs to be done there. If you are going into a web stream, you have pump to node, pump to web. If you are going to node stream, you have pump to node. which basically what it's doing is it's using the async iterator symbol on a node stream or web stream, and it's basically writing into the other. So it's calling stream.write for every chunk we get when we are iterating over an async iterator. And we have this weird edge case here with the node stream and iterable, which is the make async iterable, and this is some leftover of legacy node streams because they didn't implement the async iterator symbol, so we needed to create it for it. Cool. And another good news is that we can mix and match in pipelines. So let's say we have some content we want to take from the internet with the Node native fetch function that we can use directly in Node. If we take the body, this is a readable web stream. Instead of using a transform function, we could even go with a generator function, which would deploy an async iterator. And we can still use the process standard out, which is a regular node stream. And this just works out of the box. So you can mix and match, and you'll be good to go. In the case you actually need to change from one type to the other, you might have a node stream, and you need a web stream, or the other way around. The classes on Node.js streams implement to web and from web methods that make this basically seamless. You just pass one stream and convert it. But if you don't need the other type and you are just consuming them, probably you are best going just with a for-await construct, which will iterate over the async iterator, and this is probably the easiest way forward. But you might have that case, because let's say I want to output the contents I have fetched from the internet into a S3 bucket. I'm using the AWS SDK. They only allow to use Node.js streams, so if I'm using the fetch body, I need to transform it before I can put it into an S3 bucket. And with all this, we could all go home. We know how to handle our stream workloads, but I think it might be interesting to take a peek into what's coming next to Node.js and to JavaScript in general, because it adds something new. The TC39, which, if you don't know, is the committee that standardizes ECMAScript and decides what features come into the language, has these two proposals, which are on stage 3 and stage 2. So the stage 3 one is pretty stable. It depends still on if the implementers find any bugs or any problems with implementation, but most of it should be stable. And you can ask the question, like, usually I've heard that streams are like arrays, but over time. So if they are arrays over time, why can't I use array methods? Like, why can't I use these functional methods like map, filter, reduce? And these proposals are kind of about that. Lucky us, we have the readable node stream already implements all these functions for the iterator. This is in an experimental phase, which means we can experiment with this. And the same example we've been using throughout all the presentation, if we use this method, it results in something like this, which, if you ask me, I think is pretty much readable, and we have to write less code. I know that less lines is not always a good metric of maintainability, but I think still this is very nice. And one thing I've heard of the array methods, the original array methods like map, filter, and reduce, is that they don't do so well in performance. Most of the time, we probably don't even care so much about the difference, but usually regular for loops are better in performance because they can run all the operations and they don't have to recreate the array. So if we take, I changed the example here to make something easier. If we take a regular array and we want to map for it some number of times, maybe add 1, then multiply by 2, silly examples, but they work. They have to create the function, they have to iterate through the whole array, and you can see in the right side that you have to do all the sums before you can do to the multiplication, which means we are recreating this array in memory over and over again. And this can add pretty quick. But if we use the readable way, the async iterator way, they are lazy. These iterators are lazy, so they only produce the data when they actually need to. That's why we need the take 5 to array, so we actually force it to produce the data. But we can see something different in the output, and it is that for every element, it's running all the operation, which means it doesn't need to reproduce the whole array. It can just take one element, do all the operation, and output it without having to do all of that. And so with that, I think we can think that it might be more performant, and arrays are iterators, so we could, when it comes to the language, we could even use these methods directly on arrays, and they might be more performant. Of course, this is only at the experimental phase. Arrays don't have it yet. We would have to do proper benchmarking because we don't know from the final implementation how much overhead this will have and if it will actually be more performant. But I think there's room for hope. And that's it. If anyone has any questions, and we have time, I don't know. I don't know if the microphone.
Should we be moving towards web streams or sticking with Node?
That's a question I don't have an answer for. Probably it depends. It depends is my easy answer here. If you need one of those, then you need to stick with those. I mean, if you are using the S3 client, you should stick with that. Probably if you are in some kind of full stack ecosystem like Next.js or something like that, probably you want to be consistent throughout all your stack, and then therefore you would need to use web streams. But it depends. If you care for performance, I would say benchmark it, test it. If you have something already there, I don't see there's a quick need for migrating from one to the other. So yeah.